we introduce a role-aware virtual agent enabling adaptive navigational interaction through a multimodal large language model. Unlike traditional agents constrained by scripted behaviors, our approach dynamically interprets scene context, user behavior, and social roles to generate plausible and purposeful navigation. Our approach takes scene information, visual data, and user state as multimodal inputs to generate adaptive, role-aware navigational decisions. We pass multimodal inputs to the decision filter to decide whether to update the agent's destination. Combining ResNet features, LSTM encoded user motion, and cardinal embeddings, the lightweight decision filter reduces unnecessary computation and latency by filtering simulation steps. If the decision filter infers yes, the model then queries the MLLM to generate a high-level action plan. Our prompting strategy consists of two parts: an initial prompt and instance prompting. We construct a structured prompt including both textual descriptions and visual inputs. The MLLM response is composed of three parts: scene analysis, predicted user behavior and consequences, and a meta-action. Then, the model generates the agent's next action and destination, its rationale, and a set of path planning weights for exposedness, distance, and openness. Path planning is performed using path-finding optimization considering 5 cost terms to guide navigation: exposedness to avoid areas visible to the user, distance to regulate proximity based on the agent's role, openness to prefer areas with cover, plus high-level costs for directional bias and intent derived from the language model's output. These cost terms are weighted dynamically by the MLLM to align with the agent's current role and objective. The planner then computes a locally optimized path that balances these factors. In the playful role, the agent acted as a hide-and-seek partner for a 5-year-old. After arriving at tree 33, it initially planned to move to tree 34, but changed course to tree 23 in response to the updated scene context. In contrast, the hostile role assigned the agent as a fugitive evading a police officer. The agent initially moved toward tree 21 and tree 23, maintaining a low profile to remain hidden. Although it briefly selected tree 45, where the user was present, it quickly rerouted to tree 31 in an attempt to avoid detection. However, during this transition, it unexpectedly encountered the user. In a supportive role, the agent assists a visually impaired user by guiding them to a destination. In the video, the goal, marked with a star, is located near tree 44. At an early step, the agent guided the user from tree 33 to tree 34. Then continued toward tree 44 and tree 45. Once the user reached the goal location, the session concluded. We conducted a mixed role experiment on a shepherding task. In the baseline setting, the agent provided standard protection by maintaining flock cohesion and preventing the approach of the wolf, which acts as an active hazard. With passive hazards enabled, the agent first patrolled along the side of the wolf, which was stationary, and then moved ahead of the herd to maintain flock formation. The agent noticed that sheep 5 became stuck in a sandpit and proactively rescued it. After the rescue, the agent returned to the center of the scene to restore local flock cohesion, and then moved west to regroup the isolated sheep. In the mixed hazard setting, the dog demonstrated stronger strategic behavior. It preemptively blocked flanking routes, pushed the herd away from active threats, strengthened the defensive perimeter, and intercepted the approaching wolf, all while maintaining herd cohesion and keeping the flock positioned in a safe region. We also conducted an AR outdoor interaction evaluation to demonstrate the practicality of our approach. In the playful role, the agent initially stayed near its starting point to avoid overwhelming the user, occasionally darting away to add a light challenge. When it drifted too far, it returned, balancing playful distance with ongoing engagement. In the hostile role, the agent actively moved away from the user, maintaining as much distance as possible. When the user approached, the agent deliberately selected the farthest available object or location to reposition itself, minimizing the risk of being caught and reinforcing the adversarial dynamic. In the supportive role, the agent takes on the role of a service robot, guiding the user toward a designated goal. Throughout the session, the agent successfully navigated toward the target object, a sphere visible in the video, by remaining close to the user. Thank you for watching.